Okay. So we got to right here. And this is a calculator problem. So just FYI. Okay. So we had just talked about total distance versus net distance. And, you know, net distance is like if you're going from here to here, and then you turn around and you go back to here, and you wanted to know the net distance, it's only how far you traveled from start to where you stopped. That's net. Total distance would be from here to here. Oops. I can't do that. From here to here, plus this. It's the entire amount, which makes sense why it's called total distance. All right, so the position of a particle is given by the function blah. And P of t is in centimeters. We want to find the net and total distance. So the net distance is no real issue. We just take P of 4 and we subtract P of 1.5. And it's in the absolute values because distance can't be a negative. Now, personally, what I would do is I would take this and plug it into y equals so that I can just do y1 parentheses 4 minus, blah, blah. So that's 2x cubed minus 6x squared plus 8x. And then you just go alpha trace to get to the y1. And then put the parentheses 4, alpha trace, parentheses 1.5. What'd you guys get?
144 and 16.5.
Oh, just go ahead and subtract them. Yeah. I put them in, I went ahead and did y1 parentheses 4 minus y1 parentheses 1.5.
Oh, yeah.
Oh, yeah.
58.75.
What would the units be?
I think I'm going to get that too.
Wait.
Second? No. It is centimeters.
Centimeters.
I think you did them wrong. When you said your numbers, they said nothing like my numbers. And I'm pretty sure I got the same thing you did. I just got the math in.
Oh, I didn't have the 6x squared.
Oh, that'll make a difference.
I had the x squared, not the 6x squared.
Oh, okay. Okay, so then that's net distance. Now, total distance, you have to see where this is changing position, well, changing direction. So we're going to need to know V of t, because V of t is what tells us whether it's going left or right. So that's 3, just kidding.
That's
6, yeah, t squared minus 12t plus 8. And this is a calculator problem, so let's graph it. From 1.5 to 4 seconds, that's your x min and x max. And remember, you can hit zoom 0 after you do that. And it'll make it nice and neat for us.
What did you say the window was? 1.5 to 4?
Yes, now why did I pick 1.5 to 4?
Because
that's
Yeah, it tells us right here that's what t is. So that's x. 6x squared minus 12x plus 8, window, 1.5 to 4, and zoom 0.
I got a curve.
Yes, it is a curve. And if you look back at your window, it doesn't look, I mean, it's only going from positive. But if you went down to y min being like -1, you can see it's all above the x-axis. So let me show you.
So it didn't. Wait, if it's all of the x-axis, then it didn't change direction.
Right. Didn't change direction at all. It's always going to the right.
So it's the same, isn't it?
Yes. So net and total distance is the same. So v of t is greater than 0 for all t in the interval 1.5 to 4. So the particle is moving right the whole time. So net distance equals total distance. So they're both 58.75 centimeters. So that's always nice. It's always going in the same direction. Total distance, net distance, poof, same. No big issues. Life is good.
But on the next one.
But on the next one, we can imagine we're going to change it again.
We need diversity.
Of course we do. The position of a particle is given by the function blah, where P of t is measured in feet. Find the net distance and the particle travels from 0.5 to 1.5. So you guys go ahead and do net. And if you feel comfortable, go ahead and try to do total. But at least do net. Remember, alpha trace is how you get to y1 if you're doing it that way. What did you guys get for net?
9.367.
Yes.
Feet.
Yes, very good. It's P, and it really doesn't matter the order because you're taking, it's always absolute value.
I know, but it's better to have positive.
Yeah, I agree. So P of 1.5 minus P of 0.5 equals, yes, 9.367 feet. And I just, put y1 as P of t. Now to do total distance, what are we going to have to find?